C Physics 1992 Structure Question, Question 4. Here we have set up to measure the specific heat capacity of metal. So the data is given here. Mass of metal bulk is 1 kg, initial temperature of metal bulk 29, and final temperature of metal bulk 41. From these two data, we know that delta T would be 41 minus 29 degrees Celsius. And energy supplied by the heater is 12,300. Part A. You are asked to describe with the help of a diagram a method to measure the energy supplied by the heater. So we can actually measure the energy supply using a geometer. So we can put this setup, connect the power supply to a geometer, and connect the geometer to the heater. Okay, by this way, the energy supplied to the heater can be measured. So firstly, connect the heater to power supply through a geometer. And then turn on the power supply. The geometer would give the reading on the energy supplied. Part B. Calculate the specific heat capacity of metal. So according to the data given here, okay, so we would write down the equation. Q equals mc delta T. Energy supply is 12,300. Mass of the metal block is 1. Specific heat capacity to be calculated. Delta T is 41 minus 29. Solving this equation, that would give us 1025. We are talking about specific heat capacity, so the unit is joule per kg per degree Celsius. Part C. Value obtained in B is found to be higher than the actual specific heat capacity. So we know that C is given by Q over M delta T. So the calculated value C is higher. There are few reasons. Firstly, you can say, the Q has been measured to be higher, or delta T is measured to be lower. Okay, or on the other hand, you can say that the actual Q, the actual C is smaller. You have calculated it to be higher. That means the actual value is smaller. So conversely, these two are the possible. So one of the reasons is maybe because of the heat loss to surroundings. So to explain this, when there is heat loss to the surroundings, okay, when there is Q loss, let's say the geometer has measured 12300 joule of energy. However, because of the heat loss, actually the amount of energy stayed in the water may just be, let's say, 10,000. Okay, so some energy has been lost to the surroundings. However, when you do your calculation, you still use this number 123000. But in actual, we only have 10,000 to go into the water. So the Q is overestimated. Okay, we use a larger number in our calculation, larger number of Q. But the actual, it is smaller. Okay, so therefore, the measured energy supply is larger than the actual Q. by C equals Q over M delta T. Calculated Q is larger, calculated C will be larger. Calculated means measured. C is larger than the actual value that it should be. Part D. Okay, we have to suggest two improvements. Now you say the calculation is inaccurate because heat loss to surroundings, so let's try to improve that. We can wrap the metal block with cotton wool in order to reduce heat loss to surroundings. On the other hand, we can put some oil in the holes between the heater and the metal block so they would be directly in contact, so the heat can be transferred to the metal more effectively. So to ensure good thermal contact between the heater, metal, and thermometer. Part E is the above method suitable for finding the specific heat capacity of wood. So imagine now we change this piece of metal into a piece of wood. As you can imagine, as the heater gets hot, the wood may be burnt. This is one of the reasons. Secondly, even if the wood is not burnt, however, wood is a bad conductor. It is a good insulator. So heat cannot be transferred evenly to the whole piece of wood. So due to these two reasons, wood would not be suitable in this experiment. Wood is a poor conductor of heat. Thus the temperature within the wood would be uneven. Therefore, no, the wood would not be suitable in this experiment.